Good morning, everybody. I guess we can get started. Just confirm if my screen is visible and I'm audible clearly.
Yes, it's visible.
Great. So the agenda for today is on the screen. We'll be starting with something called as GitHub Actions, where we are going to take the CI/CD thing to the next level. Basically, we are going to see how the commit can trigger the build activity, and then the further things like the last stage of it would be the deployment package being created. And then we'll be having just a quick review of uh, the overall CI/CD concept. In real world, how does it come into picture? Where does it stand? What all things it provides us? The best practices for designing and implementing the CI/CD pipeline. And then we'll be talking about the best practices for the overall CI/CD and GitHub concepts, Git and GitHub concepts both. Okay, so let's get started. Yesterday we saw that how the code can be actually pushed, and then how the pull request can be created for the review purpose. And uh, once the review is done, ultimately it is allowed to be committed or merged back into the main branch. Once the code is committed or merged into the main branch, the next action itself is going to be the build activity. So that's something we need to understand. Few things we already discussed about the CI/CD, what CI is, what CD is, uh, what all things need to be taken care of while actually targeting the CI/CD uh, stuff. So let's move ahead and go with the next few things. Switch to the whiteboard. Okay, so just to have a quick recap, if I talk about what is CI, CI stands for continuous integration, and what all it targets, the stages which needs to be completed as a part of the build activity. So when I say stages, there has to be more than one steps or stages, right? And with CI, the two main stages are the build activity, which means compile, and then running the test runners, so that the unit test cases, the integration testing, and all other QA related stuff can be executed. And the positive outcome of which says that this product is almost ready to be going into the next stage, which could be your testing or staging or production stage. And the output is ready. This output just needs to be packaged further so that it can be deployed. And that is something which is taken care of by CD, which is continuous deployment. And why we use the term continuous? Because as soon as we commit the code, series of actions basically are supposed to run in an automated fashion and complete the task of build to deployment everything. Even for a small change in the code which is being reviewed and committed, all these actions needs to be performed. And that's why we say it is continuous integration. The biggest benefit that we discussed yesterday was getting the solution as quickly as possible, right? Instead of waiting for some service pack being released or some uh, major update being released, we can just keep on getting small updates in chunks, just like how we see the updates almost on daily basis or twice a day with your mobile applications. With that strategy, we go more agile and we do get solutions pretty quickly right? We need not wait for the updates for long, and we always remain up to date, right? We keep up with the business requirements all the time. Business need not wait for the completion of certain number of actions or certain number of changes before the release comes in. So it actually enhances the overall productivity also, right? That's what we discussed. So again, to put all these things together in a form of a definition for combined CI and CD, continuous integration and continuous deployment, how do we put it? A CI/CD pipeline consists of a series of stages or steps, as I said, that automate the process of build, test, and deployment of the software applications, right? Each stage in the pipeline serves a very specific purpose and contributes to ensure the quality and reliability of the software that is being delivered, right? That's what we have spoken about. And if I say what are those stages, let's put them formally over here. Stages of CI/CD. These are not going to be the detailed ones, but most commonly used stages I'm going to put over here. Number one, something what we call as SCM. That is something that stands for source code management. You can make a note. SCM stands for source code management. What is the purpose of it? We know this because this is where the Git discussion got started. With the help of the SCM, the source code of the application actually gets stored somewhere which can be shared with the other team members and other stakeholders and managed. So if I talk about the examples of SCM, of course, the first one that comes to mind is Git. Provider could be GitHub. Provider could be Git installed locally on your machine. The provider could be GitLabs, Azure DevOps. And then there are other providers also like SVN, Mercurial, etc. Right? What are the actions to be taken with SCM? The developers will write the code, will push the code changes to the SCM repository, code repository represented by SCM. And usually this is the action which will trigger the CI/CD pipeline, right? So intermediate stage is also there. You commit and then probably the pull request is created. After the pull request is approved, then the CI/CD pipeline gets triggered. So it all depends on your requirement. You can configure the action of your CI/CD pipeline based on exact requirement. If some complex business code is being written, business application is being written, most likely the review is something going to be very, very important, a top priority. But for simple applications where maybe the team size itself is just 1 or 2 members, you may not require the review. In that case, you may not be creating pull request. So committing your code to the source code repository itself should trigger the CI/CD pipeline. So it all depends on your need, right? What kind of application you have, what is the team size, whether the pull request is mandatorily required or not. That will decide whether the commit action triggers the CI/CD or it is the approval of the pull request that triggers the CI/CD. Understood? Yes.
Yes.
Next stage is code build or the compile activity. compile stage. Clearly, you can understand this stage is responsible for compiling the source code into some executable artifacts. Like for .NET applications, the outcome will be .exe or .dll files, which is what we call as executable artifacts, right? In case of Java, those could be some .class files, right? So it depends which coding environment, which platform you are using, right? So that's why we use the generic term, something what we call as executable artifacts, whatever applicable to your framework or the platform that you are using. So any binaries or any executables or libraries that are applicable will be prepared over here, right? Just the compilation will happen and nothing else. Your CI/CD system is responsible for fetching the source code from the source code repository or source code management tool, which probably could be Git or something similar, right? Compiles that source code and generates the build artifact. So instead of building the code in Visual Studio on local machine, the build activity will be performed on a specific server. Usually these servers are termed as build servers. Okay, the advantage of using the build server is, first of all, the servers will be more powerful machines and hence the build activity can be performed pretty quickly compared to that of your workstation that you are using as a developer, right? And the second thing is the code as a whole will be compiled. It won't be compiling only the portions that you are coding. It will be compiling the entire source code which has been committed by all the team members into the source control. Understand? So while compiling, it is not just the transformation to the executable artifacts, but if any compilation errors are also being surfaced, those will also be caught in the stage and the report will be prepared. The output of which can be then shared with the team members so that they can take care of the errors which are being surfaced. People can identify which code is failing and who has worked on that particular piece of code can then be employed to actually correct that issue, right? Troubleshoot that issue and just trigger the overall activity once again. Make sense?
Yes.
Next stage, any guess what it could be?
Unit testing.
Yeah, something on the same lines. We call this as code quality analysis. So it's not only testing, but it can include the other things also, like where if any coding standards have been set, those are being violated by some developer in the team, those can also be checked. Any security vulnerability which could be there, that can be checked. So security testing, right? Any other potential issue which might surface out of the code which has been written. So this can be clubbed up with the review activity as well, right? So for this particular stage, what are the kind of actions that needs to be taken? We need to make use of some specific tools like code analyzers, maybe, which are static analyzers, which just go through the code and check for the coding standards, whether they are being followed or not. Some security scanners, then some sort of linting tools, linters is what we call them, right? Some automated code analysis tools can be used. Most of the time, if you're working with Visual Studio, these tools are already available as the part of Visual Studio, especially if you are having Visual Studio Enterprise Edition. Your Visual Studio is already equipped with these tools. The end result is the complete detailed reports are generated at the end of the stage. And then the next stage gets triggered, which is actually a piggyback of the third stage, where we actually run the unit test cases. Right? Followed by another piggyback stage where we do the integration testing. Here we focus actually on the code execution, whether it is performing the way we want or not. Here we are doing the static analysis before putting the code through the tests. By going through the code, if we can find out if there are any potential issues, those can be fixed here itself. We focus on that. And after that, we go for the test cases. Right? Then comes the next important stage, which is called as artifact repository or build repository. What is this? Whatever the build artifacts are generated in the code, build stage, are stored in a separate repository called as artifact or build repository. So your EXEs and DLLs are stored in this artifact repository. The purpose of this is so that these artifacts can be stored and reused at a later time. Maybe you are looking to extend whatever the functionality you have already created. And from here, you can create the different build packages or different deployment packages for different environments. We say that .NET Core is actually platform independent or cross-platform environment. But then for every environment, the deployment process is different. So we need to have the different deployment packages to be built. And that's where we need to pick the source code and create the different deployment packages for different environments. And this is where the artifact repository will come into picture. So it is just like source code repository only, just one difference. Source code repository stores your source code itself, whereas artifact repository stores the compiled code, EXEs and DLLs in case of .NET. Got it?
Yes.
Okay. Next is deployment to staging environment. You can replace this with deployment to testing environment also. And that stage probably can be put somewhere here. Right? Once all the testing has been done, after that it goes to the staging, which can be used for UAT as well. Right? Because staging environment is almost the production environment, a clone of the production environment, where the actual end users are going to be put through the testing of the application. They will be just getting the feel of whatever you have deployed or whatever you have developed and will give the feedback. If any suggestions come in from them, any changes requested by them can be accommodated and the whole activity can be conducted once again, which will take less time, in fact, because the changes will not be wholesome changes. Minor changes might be suggested by them. And once they say, OK, probably that's where you need to go for the actual user acceptance testing, followed by the security testing or security scanning, and so on. In fact, with that, I can put my next stage as functional testing or UAT. Right? With staging, what is the purpose of staging? As I said, it is almost a clone of the production, right? We also call it as mirror image of the production environment. The purpose and the action taken over here is basically to put the application through the thorough testing, which includes the functional and performance testing also, including security scanning and all. And that's why I said this 8 step and maybe few more steps are piggyback of this 7 step only, right? So functional testing, what is it? Here we actually validate that the application is meeting the specific requirements placed by the end users and is behaving as per their need or not. For this, we actually make use of the automated functional tests. Test cases are supposed to be there in place. Those test cases are executed. In some cases, the manual testing can also be performed in addition to the automated testing by the QA teams or even the actual stakeholders, the business users, right? Then goes the next piggyback step, something what we call as security scanning or security testing. Security scans, I'm sorry. Security scans are responsible for identifying the vulnerabilities and security issues in the application, if any. Most of the time, in this particular stage, we do negative testing. We target the application with wrong inputs. We target the application with some security violation attacks or attempts and see if my application is capable enough to handle them or not. If it breaks at any point in time, that means I need to review my implementation, right? Fix it and then put through the entire process once again. Got my point? For this, there can be automated security scanning tools being used to check the application for any common security vulnerabilities. Okay. Next stage is once the security scanning is done, probably we can say that we are ready with the final version of the application, which can be then deployed to the production. So the stage is deployment to production. If I say what exactly is done with deployment to production stage, it's easy to guess. Once the application has passed all the previous stages, it is now required to be deployed to the production environment, right? And how this deployment is carried out so that the downtime should not be there, or even if it is there, it is just momentarily. It should not be a huge downtime. In that case, you can go for the rolling or what we call as patching based deployment, where only some components which are changed are replaced, or the new components are just added to the production environment and your application just keeps on running, right? So that the downtime can be minimized. For web applications, it's even easier because your web application can detect these changes, can keep on running the old instance for the ongoing requests, and all new requests then can be redirected to the new deployment, newer implementation by creating a separate instance of your application. And once the instance request count goes 0 on the old instance then can be shut down. So this is something which is taken care of by your web server automatically. Make sense? So downtime for web applications will be almost near to zero. Correct? Yes.
Yes.
Next stage is, any guess what it could be? We have already deployed our code to the production environment. What could be the next stage?
Verification.
And what do you mean by that?
Smoke test, like whether it is up and running.
Mhm. So don't you think before that there is one more action that we need to take? Set up the monitoring,
Yes.
which includes setting up the health monitors of your application. And maybe we can include some alerting module into that. If anything wrong or unexpected is detected, the alert should be created and sent to the appropriate people, right? We need to continuously monitor the production environment to help ourselves detect and respond to the issues in real time, right? So we need to set up the health monitoring tools, which will be responsible to collect and analyze the data at real time. If anything untoward found, generate the alerts, provide the insights into the application's overall performance and overall health, right? Next comes the smoke testing, what we call as post deployment testing also. So what is smoke testing? We just
Uh,
see whether the application in the production environment is functioning or not. And if it is functioning correctly or not, the way it should. Purpose or actions required here are to use the automated smoke tests to verify all the critical functionalities and the user flows to confirm that the deployment was successful. Sometimes the deployment might be showing successful, but maybe some components get missed, maybe due to some bad bandwidth or something, right? So in that case, we need to see whether everything is working properly post deployment or not. That's what smoke testing is responsible for. Got my point? Yes. Next is feedback and reporting. Reports and feedback from the entire CI/CD pipeline are supposed to be collected and should be made available, or in other words, we can say shared with the development and the operations team, so that if they find anything unexpected, they can just review the entire stages to find out any potential issue and fix it as soon as possible. Because if these reports are not shared, these reports might contain some failure reports also. So that's why these are very crucial. Correct? What all things it will target, those reports or the feedbacks? Precisely the code quality, the test results, the deployment success or failure, and the monitoring data. These are the things which will be primarily focused on within this stage, feedback and reporting,
uh,
right?
uh, Hi,
Yeah.
Sakit. So we have not considered here any database deployment.
See, even if it is a database, basically the same kind of steps will be applicable for that also, right? Maybe build is not required, but that build will be replaced by probably running some scripts which create and set up the database and put the seed data also into it, right?
Okay.
It's not going to be very different from what you will be targeting the application for. Understand?
Yeah.
Conceptually, it is going to be the similar kind of step. If not exactly the build activity, there has to be something similar to that. In case of database, we don't build anything. We just create the actual database objects, right? So the build activity most likely will be replaced. Got my point?
Yeah, that's right. But as a part of verification, for example, in
Yeah,
the stages,
yeah,
so
it will be included.
yeah. Okay.
And that anyways is getting targeted here also when you talk about the integration testing, isn't it? Because integration testing not only talks about individual components, but it talks about the entire software as a solution, complete solution, right? So this
Right.
will by default be targeting the database also. There will be components which talks to the database, and those components will also be included in this testing phase. Correct?
Yes. Yes.
Okay. So the last stage which comes up over here is rollback if needed. If your deployment outcome is not as per the expectations, there are some severe issues in the production environment, there has to be some rollback plan which needs to be initiated. So it just reverses the new deployment and restores your application to the previous state. But this needs to be done if and only if the severe problems are detected, right? So that you keep your deployment package in the most stable format or stable form or stable version at all times. That's why we do see those terminology being used. LTS, that is long-term support, which is the stable version. And then there is something called as current version, which is more on the trial basis, right? With many of the frameworks and technology platforms, we do see these terms being used. And for production, most of the time we target the LTS deployments, which are the stable releases. Yes or no? Now, I've listed these stages. I already said that these are not the only stages. There can be more or less stages as per the need, as per what kind of application you are targeting, right? They can vary. Yes, even the chronology or the sequence of these stages can also vary based on the very specific needs of your project and the policies of your organization as well. Understand? So to summarize it, the primary goal of the CI/CD pipeline is to automate the software development process and delivery process while also ensuring that the application meets quality and performance standards throughout the life cycle. Got it? Yes.
Yes.
Now, moving on to the next step where we need to understand what in Git or GitHub allows us to target the CI/CD pipeline or to work with the CI/CD pipelines. So here we need to focus on something called as GitHub Actions. right? Where do we see those GitHub actions on the portal, GitHub portal? So suppose this is my repository for the current application. Here we have something called as actions, where we set up the workflows for CI/CD. Based on the application type, it automatically suggests the workflows. Like for .NET Desktop based deployment, there is a suggested workflow already. If I'm looking to deploy the .NET Core app to Azure Functions, there is a workflow. .NET Core app to Azure Web App on cloud, Azure Cloud, there is a workflow. The same thing on Amazon ECS service, Elastic Compute Service, we do have a workflow. There are already many suggested workflows, so you don't need to start all the time from the scratch. You can pick up any of the suggested workflows as templates you can start. They will provide you all the basic bootstrapping, and then you can customize these workflows to suit your requirement. And if you feel that, okay, none of these workflows will help me out, I have a completely customized requirement, you can actually skip this and start with a fresh workflow which needs to be coded from the scratch by yourself. So there is a link, set up a workflow yourself, with the help of which you can create your own workflow also. Makes sense? But before we actually use this, we need to understand what actually GitHub Action is, what are its capabilities, what it can do, what it can provide me. Correct? So let's define GitHub Actions. GitHub Actions is a powerful and pretty versatile automation platform provided by GitHub itself. A very popular web-based hosting service used by developers across the world for version control using Git, and then the subsequent actions. It ideally enables you to automate various aspects of your software development workflows that include continuous integration, continuous deployment, custom tasks, and the custom workflows also, right? So practically, let's list down what all capabilities the GitHub Actions target or provide. First one is automated workflows. Once the workflow is defined, whether it is defined with the help of the ready-made templates provided out of the box by GitHub, or it's a custom workflow. Once it is in place, the execution of these workflows is completely automated. Right? It is just like a script which needs to be executed. The script is usually created with the help of YAML language, YAML. Yet another markup language is the full form for YAML, right? There is a specific syntax that needs to be followed so that the YAML interpreter can understand what you want. Okay, so practically the automated workflows are provided by the GitHub Actions that allow you to define and automate your workflows using the YAML files. These workflows then can include multiple jobs, tasks, steps, etc., making it easy to orchestrate the complex processes. Right? If I talk about some of the commonly used use cases, this process or this feature automated workflow can be targeted for creating the workflows for build, test, and deployment of the applications. There can be one single workflow which does everything. There can be three separate workflows targeting different areas. It all depends on my need. Okay. Is it clear?
Yes.
Yes.
Next is CI or continuous integration. So basically you can set up your CI workflows to automatically build and test your code whenever the changes are being pushed to your repository. Optionally, the reviews are being conducted with pull requests. I said optionally because it may not be the case that the review is required all the times. Correct? As we discussed earlier also. These GitHub actions support a very wide range of the programming languages and the testing frameworks. These workflows help catch you the bugs and ensure the code quality early in the development process, which helps you avoid the issues later on. Because issues surfacing later on in the process will be hard to troubleshoot and will be time consuming to troubleshoot as well. Correct? Clear?
Yes.
Next thing is CD. CI is always followed by CD only, so it's easy. What CD is, we know. So what Git actions or GitHub actions basically do for it? The GitHub actions can be used for creating the workflows for continuous deployment also, to automate the deployment of your applications to different environments like staging, production, etc. Once your code has passed the continuous integration test, you can then deploy the application to different platforms like local web servers, network web servers, cloud platforms, or if you are targeting the containerized environment for the deployment like Docker or Kubernetes, you can go for that also. And there are many more options that we have. Again, it depends on the kind of application also, whether it's a thick client application, whether it's a mobile application, whether it's a web application, or a proper thin client application, whatever. The deployment will be targeting the specific environments. Correct?
Yes.
Next, you can also use these workflows or GitHub actions for implementing custom automation tasks. This is something which is beyond CI/CD. As the GitHub actions allow you to write your own code also, it does allow you to automate various custom tasks that could be related to your project, which might include document generation or generating documentation, sending some notifications to the stakeholders, publishing the packages like NuGet packages in case of .NET, or even performing data migrations. If you are using the entity framework into your project, the data migrations may also be required, and the automation for that also might be required, right? Especially if your application is not following the automated migrations. If it is depending on the manual migrations, then somewhere you need to trigger it. So your custom automation task can target it. Got my point?
Yes.
Next is job scheduling. The GitHub Actions also provide the scheduling capabilities, which enable you to run the jobs and different workflows at specific times, or maybe some regular schedule, like every 2 hours, every 3 hours, every 10 hours. I need to execute something or I need to execute some job, right? This might be useful for some tasks like the automated backups, data synchronization, and maybe also some periodic maintenance, right? Next is event-driven triggers. The actions can be triggered by different GitHub events, as we discussed earlier. When I push the code, I can have some action triggered. When the pull request is approved, means the merge activity is performed, I can trigger the GitHub action. Whenever some comment has been put, I can trigger the GitHub action, and so on. There are different types of events which might occur on GitHub. It ultimately enables you to create the event-driven workflows, which will respond to specific actions into your repository. Clear?
Yes.
Okay. Next is matrix builds. You can define the matrix builds for testing your code against different versions of the dependencies that your application might have. Not only the dependencies of the application, which are direct dependencies, but even different versions of operating systems or the environments simultaneously. Basically, to ensure the cross compatibility or cross platform compatibility and even more broader coverage in your testing. Understood? So create multiple builds, multiple deployment packages. Try simulating the runs of those packages or those versions on different environments and see if all are performing the way they should or not. Fix any issues being surfaced. So this is something which can be done in parallel, saving your time. Yes or no?
Yes.
So with that, the next one comes as parallelism. Where the GitHub actions allow you to run multiple jobs or steps in parallel to speed up your workflows and reduce the overall execution time. Anyhow, the processors that we have these days are all multi-core processors. So they are already capable of supporting the parallel jobs. Yes or no? So we don't depend entirely on multi-threading for parallelism now. Multi-threading never actually provided the real parallel execution. Just that it simulated the parallelism by switching between the different jobs and tasks quickly, very, very quickly. So it used to appear like multiple jobs or tasks are running in parallel, but technically that was never the case. With multi-core processors, multiple tasks can run parallelly. So even if we have one thread per core, and if we have quad core processor, 4 tasks can run in parallel. Yes or no?
Yes.
Another thing which GitHub Actions do support is secret management. Any idea what these secrets could be? For .NET assemblies, many times we use signed assemblies, right? So we use some key value pairs. In fact, some strong name key pairs, private public keys. Those can be your secrets. Your user credentials can be secrets, which might be required at different times. Application to application authentication were happening. Your application talks to an API, and that communication needs to be secure. So your application identity as a credential needs to go to the API. There can be a possibility of using API keys, right? So all these things are something what we call as secrets. And being secret, they need to be managed in a secure environment. They needs to be stored very carefully. So usually your secret documents like property papers and the FD documents, your investment related documents, do you keep it open or do you keep it safely in some locker or something? Even if it is at home, most likely, I hope everyone agrees that we keep such things in a locker. So whether locker at home or locker at bank, it goes in a locker, right? So such locker is provided by your GitHub Actions by secret management module. So you can store and access all of your secret information with the help of GitHub Actions. These secrets, while getting stored, are stored in encrypted manner for additional layer of security and can directly be injected into your workflows as environment variables. Is that clear?
Yes.
Then the next thing that we have is community contributed actions. Specifically important if you are using a public repository, right? So practically GitHub has got its own marketplace for community contributed actions. Basically, community of developers will create different workflows and put that into the marketplace. That can then easily be integrated into your own workflows for your applications as per the need. These actions usually cover a wide range of use cases, and if required, you can also create your custom actions on the top of them or in parallel with them. Understood? Yes. Next is workflow visualization. GitHub itself provides a visual representation of your workflows. So basically, you can see the steps like flow chart. That makes it easy to understand the flow and the status of your automation as well, with some color coded indicators like green, red, yellow. Yellow means executing, green means executed successfully, red means failed execution, right? You can easily find out what is the state or status of your workflow. So that is something which is provided by the workflow visualization. Clear?
Yes.
And then comes,
Saket, could you please explain about the parallelism once again?
okay, so parallelism basically allows you to run more than one task at the same time. Real time parallel execution. So suppose if I'm having, I'll explain with the help of the code based example, it will be easy for us. Suppose you have got the task of calculating the total of the numbers between 1 to 100 and calculating the multiplication of all numbers between 1 to 100. So one is 1 plus 2 plus 3 till 100, and the other task is 1 into 2 into 3 into 4 up to 100. So usually the way we code, it will be a sequential activity, right? The most usual one. We can use a for loop, and with the help of which we can get both the series calculated. Yes or no? That's the most natural solution. Yes or no?
Yeah, so basically you're saying
Now,
asynchronous.
of course, parallelism means as
Parallel.
asynchronous activity will definitely be applicable, right? But let me come to the next thing. So this is the most natural thing where one by one you will be doing. If you want both of these loops to execute together, the first thing which will hit your mind is use multi-threading. Create two threads. One thread does 1 plus 2 plus 3 up to 100. The other thread does 1 plus 1 into 2 into 3 up to 100, right?
Yeah.
Now, tell me whether these two threads will really be executing in parallel. They appear to be, but they don't, because processor allows only one thread at a time to go into it and do the job. Am I right?
So for multi-core processor,
No,
it will
I'm
take a
talking about
separate.
single core processor. Even
Yeah,
if it is
single core.
multi-core processor, even if
Mhm.
it is multi-core processor, the default handling of multi-threading is one core for the entire application. Yes or no?
Yeah.
Until and unless you don't use the task parallel library in .NET, the multi-core processor capability will not be utilized.
Mm.
So the real parallel execution won't happen. It might be the case like 1 plus 2 is done in one cycle, 1 into 2 is done in the second cycle. Then again, the result plus 3 is done in next cycle. And then the result into 3 is done in the next cycle, right?
Then in that
They will,
case, why do we have a like if there just appears to be a parallel
yeah,
task,
but
but
the
they're not actually there? Yeah.
switching is so fast that it appears that, okay, both are running parallelly and they are synchronized with each other, right?
Yeah, but
Now,
our generally as a developer, the assumption
I
would be
I
both are
100% agree.
independent.
I 100% agree with you. That is the problem which we as a developer were facing, right?
Yeah.
Multi-threading didn't give the real-time parallelism at any point in time, and that's why for very complex and heavy duty code, uh, the use of multi-threading was not effective and was not optimized as well. So that is where probably the advancement was required. And then came the processors with the hyper threading capability, which was introduced by Intel. If you remember Pentium 4
Yeah.
with HT hyper threading technology, which allowed two threads in the single core at the same time. So it divided your processor into two logical processors. It was not dual core processor, it was a single core processor only, but with some technology improvements, they allowed two threads in one CPU cycle.
Mhm.
So which shown us the way for the real-time parallelism. But then people realize that it is just logically divided, right? Why not physically have two cores or more than two cores? So where we got dual core, quad core, octa core processors, and even the number of cores are increasing day by day. Because anyhow, we saw that the processor at that point in time already reached the peak of its clock speed, right? Some 3.5 to 4 gigahertz was the peak, beyond which increasing the clock speed of the processor was resulting in so much heat that processors used to melt. That's where people thought that, okay, now here onwards, we cannot advance it further. We need to have multiple processors, but then handling will be difficult. So let's pack all the processors into one assembly, which gave the way to multi-core processors. And then multi-core processors also got the hyper-threading model. So each core was allowed to be divided into two logical cores as well. Correct? So if you have octa-core processor with HT enabled, you will typically have 16 logical cores. Means 16 threads can run in parallel. And that's what the parallelism takes advantage of. Anyhow, if your system is not a multi-core processor based system, it's an old server with single processor only, single core processor only. In that case, it will fall back to the implementation with multi-threading only. That's automated. That's how the software is written. But if multiple cores are there, why not take full advantage of it? We pay for all the cores. So why not take full use of or full advantage of each and every single core which is there? Make sense or not? Yes.
Yes.
Yes, yes.
So I hope this is clear now.
Yes, Saket.
Okay. So moving on to the next feature, that is extensive ecosystem. GitHub Actions integrates seamlessly with other GitHub features like issue tracking, pull requests, code reviews that result in creating a cohesive and integrated development experience. Plus allows the customization by creating your own extensions as well. So the behavior of the entire system can be controlled as per your need. That's what the extensive ecosystem is. Clear? So let's summarize what we discussed with GitHub Actions. GitHub Actions is a pretty flexible and feature-rich automation platform that empowers you as a developer and teams to automate different aspects of the software development lifecycle. Whether it is a need to streamline your CI/CD process, automate the custom tasks, or responding to specific GitHub events, the GitHub Actions does offer a wide range of capabilities to enhance your overall development workflows. Clear? Clear?
Yes, yes.
Okay, so the next will be the implementation where we'll see how to create a simple CI/CD pipeline using the GitHub Actions. And the project that we'll be targeting is our .NET 5 API, the same project which we have been working with that we created here, which has department API controller into it. but that we'll see after the break. So let's take a break here and we'll resume the session at 11:05. Okay.
Yeah, thank you.
Okay, Sagar.
Hey guys, I'm back. Shall we proceed? Okay. So as we discussed before the break, it is this application which we will be targeting to be used for the CI/CD example. We'll be looking to create a CI/CD pipeline, set up a CI/CD pipeline on this, and which will be building our application. Optionally, if we have the test cases created here, the test runners needs to be executed, and then the deployment. And for simplicity, I'll be using the self-hosted environment so that the application can run on its own as a standalone application, much similar to what we do with this. This is going to run this application in a standalone manner, right? So that's what I want after deployment. If I want, I can just change the target to uh, any web server on any environment like Windows or maybe Red Hat Linux, SUSE Linux, Ubuntu, or whichever other OS I want. Okay, so for simplicity, as I said, I just want the self-hosted environment. For this purpose, I need to create a YAML file which will be having our uh, CI/CD setup code into it. So for that, I just open this project in rather solution in the file explorer and see the directory structure over here. I do have some .git XYZ files. I don't see any specific folder created over here, which is containing the Git or GitHub related files here, which I want to create now. So let's close this and let's add a new folder over here into the project. So just right click on your project, add new folder. The name of the folder I'll give as .github to notify that this folder contains all GitHub related stuff. And in this folder, I'll create a subfolder as well. So right click on .github folder and say add new folder. I'll name this as workflows. All of my GitHub workflows I'll put in this. Okay. If it already exists, you need not do the creation of the folders. But if the directory doesn't exist, you have to create. And in this workflows directory, now I want to create a file which will contain my YAML definition. So right click on the workflows folder, add new item. Let's try searching for YAML. If there is a template available for YAML files, I can directly use that so that the extension .yml it automatically takes. So I do find one. If not, you can just go with a text file and within double quotes, give the name of the file with .yml extension explicitly, right? So here I'll name this as .NET dash web API. The name could be anything. As I've created a .NET based web API, I am naming this as .NET dash web API dash CI dash CD to understand that this is the CI/CD example. Extension, whether I provide or not, in this case, it's okay because the YAML file I have selected. If I want, I can just say .yml. And as I said, if YAML template is not there, you can select the text file and then put the full name with extension in double quotes like this and just click on add. What's wrong? Hyphen is fine. So maybe the .yml extension, it is not allowing me for now, as by default YML extension it is supposed to take. Let me remove that, add. So if it is a text file, it would have taken that. See, anyhow, the extension that has come up over here is .yml only, right? This is what we want. Okay, now this is your YAML file within which we want our CI/CD pipeline to be configured. So I start with some YAML code. I say name, colon, one space, whatever name I want to give. So let's say it's a .NET Web API. So I say .NET space web space API space CI / CD. Okay. Then I have another property on two spaces. It's very important over here because that says that this is a subtask inside this. So each subtask is created with two spaces. And if subtask has got its own subtask, there will be 4 spaces. So that's how we handle it. Here I say the subtask is push. Push has got its own subtask. So 2 spaces it has already taken. I set it like this. And here I say branches. Under branches, again, a subtask needs to be created. So I say space, space, and then hyphen main is what I want to target. This is the name of the branch that we need to pick up. And if you remember, we created the branch with the name main only. Let's go and verify that. Code. And here we do have 2 branches. One is main and one is feature improvement, right? This is the branch name that I need to specify there. So what we have put is correct. It's the main branch. Next, here I have jobs. Now here you can see exactly this is the name of the CI/CD pipeline. On means the event I'm configuring. Event is push event. To which branch the push event is being monitored is for a branch with the name main. This is the meaning of the code so far. And then jobs will define what needs to be done. I can replace push with merge also, so that whenever the merge action is performed, then only the jobs will be triggered. As I said, this is all depending on your need, right? I hope this is understood. Yes.
This job is for
Action. The actual action means this is event. When this event occurs, what needs to be done is configured by job. So what I want is the build activity to be triggered. Now build, where the build needs to be performed and what needs to be built. That's what I need to configure here, right? So that goes next. Build, double space. In fact, quadruple space. And here I say runs dash on colon. Which platform I want to run the job on. Understand? So here I'm targeting self-hosted environment. So here I say self-hosted. If I want it to be hosted on Windows, see here I have the list of all the platforms. Windows latest 8 cores, Windows 2022, Windows 2019. These are the server editions, right? 2022, 2019. Then Ubuntu is there, then Mac OS is there. And then we have self-hosted as well. Correct? So here for now, I'm going ahead with self-hosted. Okay.
Self-hosted means
Yeah.
it will run in our local.
In its own process on the local machine where the deployment happens. Understood?
Yes.
So one blank line I'll leave here, and then I say the steps that needs to be carried out for build goes in here. Double space here at the level of steps, hyphen, space, name. This is the step name, colon. Let's say it is named as checkout code. And then again on the same level, it says uses actions slash checkout at V2. So some version labeling. Okay. I have another step, so I leave a blank line once again, double space here. On the same level as where I configured the step 1, I have step 2 with again hyphen space name being set to setup.net. And then on the same level as name, I put users, actions, slash setup dash .net. These are all preset actions into the GitHub actions at V1. Okay. And then I say with which version of .NET I want to use, that I configure here next. 2 spaces at the level of width where I say .NET dash version is 5.0.x. So base version is 5.0 and then it can have some subversion. If I want specifically 5.0, I'll just put 5.0 only. Okay. Then there is another step. So again, I go on the same level as name and I have the next step with hyphen name. Once the .NET is set up, I can build my code. So I name this step as build. And to build my code, I need to run the command .NET. .NET build rather. So at the same level as name, here I'll say run .NET build which configuration to be used. So I want release configuration. Hyphen configuration. If I don't mention this by default, it will use the debug configuration. So all your PDB files also will be included, which I don't want. Your breakpoints also will be processed, which I don't want in the production environment. It depends for which environment you are actually building this. So if it is going to be testing environment, you might want debug configuration. If it is for staging or production, it will be release, correct? Then the next
This,
step is, yeah.
This run command is nothing but our CLI command, right? .NET build.
Correct. .NET build is the CLI command.
Okay. And
Next
name
step is, yeah.
Name is
Name
not
can
a
be
predefined.
anything. Not a predefined. It can be anything. It should be descriptive name so that you, anyone can understand what kind of activity you are actually doing. Now, why this name is required? Because if there is a dependency of one step on the other, you might need to refer that step, right? That's where name will be required.
Okay.
And you cannot have any step which is anonymous. You have to give some name. Understand?
Yes.
So next step is test. Command is run, and there it goes for CLI command .NET test. So this is my CI pipeline, right? Prepare the environment, build, and then test. After that, what should be done? The CD pipeline comes now, right? This should be on the same level as build. So here I go to the root, then 2 spaces, and then I say deploy. Under deploy, I need to set up the dependency. I can deploy if and only if the build action is completed, right? So here I say 4 spaces. To set up the dependency, I say needs build activity to be completed. So here I say build. Then I say runs on. The environment self hosted again. This should match with what you have built. And then the steps for the deployment that needs to be carried out. So one blank line. There goes steps. Double space, hyphen, space, name. Let's say I call this as deploy to production. Then run. Pipe symbol. If multiple command needs to be executed like that. So here I just want my operating system's echo command to be used. And for that, I just go first of all at the level of run and then 2 spaces. There I say echo. So that on console it displays some message like whatever I give here in the codes. Deploying to production. ...
Saket.
Yeah.
Yeah, one more query.
Yes.
Actually, in deploy section in needs, we have mentioned build. This is nothing but the job, right? Above job.
Right.
And
Correct.
if we have
Build is
multiple,
one job and deploy is another job.
okay, so we need to when we are going for the deployment, then that it's a prerequisite that build should be taken.
Completed.
So we have,
yes.
okay, and if we have multiple jobs, then we need to mention in separate line or means what is the procedure? Means if
Yeah,
there
it
are
should be a separate section, not line. It should be a separate section. So build is a separate section and deploy is a separate section, right?
yeah, but in deploy in needs right now we have mentioned only build. If we have suppose build one
Yes.
is their job, so how we
It should be
can
comma
comma
and
separated?
comma separated. Yeah.
Oh, okay, okay,
Okay.
good. Yeah.
Okay. So here now what we need to do is save this file. And we need to get this committed as well. And push the workflow file to our GitHub account, right? GitHub repository, I mean. So how do we do that? I just right click on web application and then go to Git, commit or stash. I'll say GitHub action defined, or probably we can also say with CI/CD, right? Commit all, and then I say push.
Here, echo means it's just like a log.
Yeah, correct. Okay, so here my content has went to feature improvement and where I need to say compare and pull request, create pull request, and then for now I just directly say merge pull request so that it is merged within main branch. Right? I go back to code and here I can see in web application, my GitHub workflows also has been defined. So integrated within my application, right? Let's see if it shows up over here. We could have created that file here also by saying set up a workflow yourself. All the YAML content we could have provided here. See, it automatically targets this directory. Yeah. So one and the same thing, you create it in the local machine or you directly put it over here. Here is your file and you can see the code directly here. Yes. Next question is how do I run this? Any idea?
If we go to actions, it would be already running. Build.
So if we go to actions, then where do I
Yes, sir.
monitor?
Configure.
Actually, for me, when I merged it to main branch, it automatically
Yeah.
started the actions.
Ideally, it should because that's how we have coded, right? But where do we monitor it? Maybe to simulate this, what I can do is I can add one more content file here. Let's say under models, I add class called as EMP.
Actually, what we are trying to check, Socket?
My pipeline should have been activated, right?
Yes.
That's what.
But
Let's say here.
have we created the pipeline? So the YAML only we have created that one, right?
That should have executed, and we should be able to monitor that also, isn't it? Just one moment, I'll get back to you. So let's say this is some additional stuff and I directly check in into the main branch. So here I say get commit or stash. It detects the change. I directly put it into the main. And I say commit. Okay, message is missing. So added EMP model is the commit and push. Pull then push. If some mismatch is there, it automatically detects, right? So it said that first pull it and then push it. If there are some remote changes which it finds, it will pull it and will push it then.
Actually, Socket, we have only created the YAML file, so that itself it's enough, or we need to.
That itself is enough. The reason behind that is if you see the content of the YAML file, there we have already configured an event, isn't it? Runs on, the event is here. When I push to the main branch, automatically this should run the list of jobs, right? It's an event-driven workflow I have created, so it should have run. Wondering why it's not showing up over here.
Actually, I'm not understanding. So by creating the YAML file, how will it identify it should run? Because we are not mapping that file anywhere. So how the GitHub will automatic?
Yeah, just one moment. I'll get back. Looks like I'm lacking with some configuration in this account. Okay. Okay, yeah. So I'll just see on my machine, I guess there is no connection with my GitHub account. That's why I'm not able to see the task running. And that's where your question is like, how did it detect automatically? So for that, there is a tool called as uh, task runner, which needs to be running on your machine, which will detect your YAML file automatically and will run it. And that's what was missing here. So if you see, I have my YAML file already into place, but there is no task runner or the GitHub runner, action runner configured on my machine. So what I did is I went to settings and then actions, and then here I have the option of runners. It says there are no runners configured. So here I say, as I'm targeting self-hosted, so here I say new self-hosted runner. The target OS I select Mac OS, Linux, Windows based on what my machine is based on. My machine is a Windows machine, so I select Windows, and then the architecture, whether it is going to be 64-bit processor or it is ARM processor. And here is the script which I need to download and execute. So I just copy this entire script. Or probably one by one, I can also do that. So let's copy this first command. I open PowerShell, as the script seems to be the PowerShell script. I go to the root folder, and here I create a directory called as action runner and switch to that action runner directory. Done. Then the next command is invoke web request, which is basically to download the latest runner package for Windows 64-bit architecture. It ideally downloads the zip file. I copy this command and go back to my console and paste the command and run it. So it downloads the runner package. How much time it takes depends on what is the size of the file and what kind of bandwidth you have. It's done. I go back and then go with the validation of the package. So this is the command for validation. Basically, the integrity check I perform with this command. I paste this new command, press enter. If no error, that means the integrity is intact. Then I say extract the installer, copy this, paste, enter. So this will unzip the zip file containing our installer. Then we say configure the runner and start the configuration experience. So copy. This is for configuration. Connects to the GitHub account. Then asking for the name of the runner group to add this runner to. So I'll just press enter for the default name. I'm okay with the name suggested, Sakit K. That's my machine name. So by default labels, it takes as self-hosted, which we are referring to in our YAML file. And then Windows and x64 for the architecture on which the runner is going to run. I'm okay. Any additional label, if I want to add, I can add them comma separated. So right now, no requirement. I just press enter. Working directory, by default, it suggests underscore work. I'm fine. So I just press enter again. Whether I want to keep the runner application running as a Windows service, yes. So that next time I don't need to do all this again. Okay, so I need to be running this in administrative privileges mode. For that, I'll just open the PowerShell in admin mode. Run as admin. Yes. Here comes the PowerShell in admin mode. And the last command, add type, is what will execute again. Okay, it didn't find the file. Oh, yeah, I am in the wrong directory. So I go to root, then I go to actions runner. And there I issue the command. Okay, config file already exists, it says. We'll delete that config.cmd. It's gone and I run the command again. Okay, so template file also I need to remove. This is a one-time configuration. If you have already done this, you need not do this again. Many things already configured. So say remove all CMD
Yes,
files.
yeah. Runner CMD already. That also we need to delete. Run.cmd.
Yeah, I just want the whole configuration to be made again. If anything is missed, it will be taken care of, right? Okay, just give me a moment. Delete it from here itself. C drive, actions runner, except the zip file, I'll delete everything. Run.cmd will just run it locally and not as a Windows service. I want this to be running as a Windows service also, right? So we download it. And now I just run this command again. Okay. So as a Windows service, it's already running. I can have a local session also triggered for now. So, okay. Listening for jobs, and now we should be able to see all the outputs. Let's say I add another model to trigger the YAML file. Let's say orders or maybe customers. Public int ID. Save. Right click on application, git, commit, added customer model. Directly in the main branch I want to commit all, and then push.
I think you need to raise PR.
It's not needed as per our workflow actually, because we have said on push you have to get this done. Right. So if you look at the YAML file, the event is pushed to the main branch. If I say it is merge request or pull request, then basically I will need that. Push to main branch should be enough.
So you have directly pushed to main branch.
We can. And right now I did that only. I pushed it to the main branch. So we can check that here. In fact, in the code, my new stuff must have been pushed. If I go to models, I do have customer already. So that confirms that it's in the main, right?
Yes.
Okay, still it's not showing anything. That's strange. Anybody got the desired result? Can you share your screen once?
Yes, again. The build
Yeah,
and
please.
deploy are completed for me.
Yeah, please share your screen and just add something new and commit it so that we can see the same process. Okay. So first share your screen.
Yeah, just a second.
This machine for me is actually a newly configured one, and there are some issues with it. I'm still figuring out and fixing the same. This message must come up somewhere on the console.
Shall I share the screen, sir?
Yeah, please go ahead.
So for me, initially, this workflow did start, but it was stuck there because there was no runner.
Yeah,
So when the runner was started, it automatically picked up those two
correct.
jobs, build and deploy, and both are done.
Yeah, this is what I wanted to see. So just add some more code and check it into Git. I mean, commit to Git so that we can see it in practical. What I was trying out. Just add another model, maybe customer model, employee model, anything. Add one property to it.
Okay, I need to.
So in your case, your main branch is master branch only, right?
Yeah,
And I hope in the YAML file you have mentioned master.
yes, correct.
Just open the YAML file once.
Yeah, yeah. It is master branch.
Yeah. Push. So because you are adding it in the branch, you have to create the pull request and merge it, right?
Yes.
Other way around, you can directly commit it to and push to the master branch itself. Under actions, now it should be showing the queued
Yeah, it's showing
job.
the new one.
So it must be running right now. The build is going on. Once build is completed, the deploy activity will be performed. So guys, just look at the steps, how it is carrying out the things. Each step is actually expanding to more commands ultimately. It goes to setup.NET now. Once .NET setup is done, it will go to build, where the .NET build command will run. Once that is done, it will run the test runners. Now, because our project doesn't have any test cases, it will just bypass it. But the moment you add the test cases, it will run the test cases also. And if test cases return positive output, then only it will move to the deployment. Okay, so here it's completed. The deploy has started now. So you can go to the deploy step. That's the echo prompt, deploy to production, and it says job completed. Okay, so complete workflow you can actually see over here. On the left hand side, you can see run details also, where it shows you some details like the resource utilization and workflow file itself, how much time it took for which task. So build and deploy both. And then if you click on build or deploy, it will show the subtask also with their timings. So click on build here under usage. Go to usage first on left side.
Yeah.
Then click on build. So yeah, so it moves there, and it there on the right hand side, it is showing how much time it has taken for each of the subtasks, right? Like 4 seconds for setup job, checkout code 22 seconds, setup.net 9 seconds, and so on. Yeah. And the way how I connected my console, actually, this output comes on the console also. Understand? If your console is running, and if it is configured as a Windows service, probably then there is only one way to see the output from your task runner, which is on the portal, because Windows service doesn't have any UI. Correct?
Yes.
So Saket, now it is
Yeah.
deployed to production.
Yeah. So I hope this is clear to all.
Yes.
In my case, the runner configuration seems to be having some problems. I just need to troubleshoot and configure that correctly. And once I do that, by default, it will be just working the way how we saw it right now on the Archit screen. Yeah. And that's just one time activity, nothing else. Okay.
Okay.
So Saket, I was asking, now it is all
Yeah.
done.
Yeah.
Like we have not given any server specifically where it will be running, like a URL. So now if I
Yes.
need to check it, how will I check it here?
You mean the output of the deployment, right?
Yes.
Okay, just go to the portal, GitHub portal. And there you can go to code. Go to GitHub workflows. In the list below. Yeah, the first folder. .github/workflows. Usually it comes up over here only. Just one moment.
Sharma, you had administrator privilege to open the PowerShell in administrator mode.
Yeah.
For me, it is not allowing. It's asking for the password.
Yeah, you need local admin rights for that.
They are not giving to the laptop.
Yeah. Yeah, so basically, if we look at our YAML file right now, we have not given any target there, right? We need to have one more step over there to be added, like set output, wherein we will specify where the output will be placed, whether it is going to be on a on the repository itself in a specific directory, or whether you want the deployment to be placed on cloud or maybe some other target. Because we have just given one step there, that is echo deploying to production, it is ending up there itself.
Yeah.
So if you see your console, it just shows deploying to production, right?
Yeah.
As per our script. So you need to specify the target explicitly where it will place the output. Okay.
Okay.
So just go back to the portal and where the workflow configuration we started, the actions tab I want. Just click on actions. We can see how exactly this needs to be done in a very easy manner. Okay, it is showing the YAML file. How do I add another? Just click on new workflow on the left
Okay.
side. And choose, let's say, the third option, deploy a .NET Core app to Azure Web App. Click on configure. And look at the jobs section of the script, within which the deploy section should be there downwards. So we do have .NET publish command, and which is actually deploying, right? So we are specifying the target there.
Okay. URL.
Right? And just go back one level. Again, create a new workflow. Discard it. Yeah. New workflow. And this time select the first option. If on the local machine you want .NET desktop. Go back. Go back.
Okay. This is Azure function.
Yeah, this is Azure function again only. So new workflow. The first one, .NET desktop configure.
Okay.
Click on the configure. So instead of URL, here you will have the local path. Go to the deploy section. Just see where the deploy section is starting up.
This is build. Then steps is checkout. This is build only.
Okay, so build activity itself is directly creating the MSIX, the installable packages. See, in the project directory itself, it is going to create a subdirectory called as app packages, within which the installation file will be placed, MSIX. See the last line, last two lines, line number 114 and 115.
Yeah.
Understand? Okay. So we do specify the path explicitly where we want the output. Got my point? And because our script had only one echo statement, it just showed us echo statement only over there. I mean, deploying to production. So if we replace that echo statement with the actual actionable thing, like deploy to Azure, deploy to local folder or something, it will just get that done. It will build the MSIX file and will put it into the directory that we have specified the path for. Clear? Yeah.
Okay.
And you have lots of input from those ready to use templates which are there, right? So you can actually build on the top of it. If you see what they're doing is they're creating the YAML file only, and which is completely editable. So whatever the default configuration is there, they have taken already that into account. You just need to customize that further. Correct?
Yes.
Okay, so let's move on. So exactly if we see the use of the real world CI/CD pipeline, how does it help? And if the CI/CD pipeline or CI/CD workflow is not in place, what will be the process of deployment? What we will do?
So, previously we do like manually publish the code in local and push
Yes,
from the any tool to server. So it's a manual process. It's error prone and it's a time taking. Every day you have
right,
to do tedious work.
right. So
So it will
installables
save the
also we
time.
used to create manually, right?
Yes.
Each and every task which we required was supposed to be done manually. Run the
Yes.
build command, run the test runners. By some uh, reason or because of some reason, if we just forget running a specific task, it will be resulting in an error prone output, right?
Yes.
Now here, your deployment itself is based on a script, which is a code in itself. That code also can be reviewed by the entire team to ensure that none of the step is getting missed before finalizing on the YAML file, right? After
Yes.
thorough review and thorough testing of the YAML file, we say that, okay, now this can form our CI/CD pipeline. Why do we say this as a pipeline? Any idea?
It's like a flow, one by one flow.
Correct. In a sequence, one by one, the tasks are executed, right? Do this, do this, do this. We practically saw that happening on the screen, right? Task
Yes.
one completed, then task two completed, then task three. And then the dependency graph was also created where we had two jobs, mainly build and deploy. Once all subtask of build activity or build action was completed, then only the deployment action got started, right?
Yes.
Okay, so all dependencies can be managed together, and being an automated solution over here, it is less error prone, correct? Because the
Yep.
script itself is tested before finalizing it, right? And when we are going manually, there is no way to test the manual actions, correct? We might say that, okay,
Yes.
there will be team sitting together and will be one of the team member will be taking care of the deployment. Now, that will be waste of efforts and time. The entire team will be engaged in just one simple deployment process. Is not feasible, right?
Yep.
The time can be actually uh, utilized better by allotting some different tasks, maybe doing some new work at that time, or maybe moving on to a different project if this project seems to be completed. Correct? And
Yes.
in fact, not a single person required to oversee this. You just need your review actions to be completed. The pull request needs to be approved. There onwards, your automation takes over, right? And maybe one of the person in the team from the operations team basically can go and verify all the output. We are getting the complete report there to say everything went well or something failed, some issues were there, and then probably the team can be involved again as per the need. If the outcome says that the issue is with one specific feature, only the person who was responsible to build that feature can be involved to troubleshoot, right?
Yes.
So overall productivity is enhanced, plus the earlier error prone approach is now actually being the automation is no more error prone here, right? Because your automation script itself is thoroughly examined. So you are getting less error prone solution at the end, right?
Yes.
We'll not say it is 100% issue free. There can be issues, but ultimately over the time, those issues become zero. We learn with whatever the mistakes we are making or whatever the feedback we are getting, whatever reports we are getting. Reports are automated as well. There is no human being sitting and preparing those reports. So the reports will be much more honest. So removal of the issues also will be much more easy with this, much more effective with this. Yes or no?
Yes.
And this will just go on happening again and again whenever we are checking in some code. So the moment we check in, we can create the pull request. Pull request, once approved and the merger with the main branch is performed, automatically there onwards, the CI/CD pipeline can get triggered. And the trigger action we have already mentioned in our YAML file itself. The very first section of your YAML file, once again, you can visit and check. The first section is on. So there we have options like on push, on merge, on whatever. So automatically the trigger will be performed, right?
Yes.
So what is artifact repository here? What is the role? In case if I don't want the local machine to hold my output, I want my Git repository should create a dedicated repository for holding all the compiled resources. I can actually edit my YAML file to redirect all the output to the artifact repository also. I just need to specify the repository path there, right? Instead of local path, I'll give repository path. So all the output will be placed over there, which can be reused later on. Now, this YAML file can also be configured in a way where it prepares the infrastructure on its own. I mean, if you are deploying a desktop application, probably you are targeting some container or you are targeting some virtual machine. It could be deployment to cloud also, where you are looking to deploy to app service or deploy to a Azure virtual machine. The whole infrastructure also can be created with the code itself. And there we use a term called as infrastructure as a code. Understand? You can use the Azure ARM templates for the automation, which can prepare your virtual machines, your servers, your databases, your virtual networking, everything. This is on cloud, not only Azure, it could be on any cloud. You can also include the tools like Terraform for easing out the automation of the deployment of the infrastructure resources, right? Terraform is a
Yes.
cross-platform tool. Then there are platform-specific tools also, like Azure uses ARM, Azure Resource Manager. AWS uses CloudFormation, right? So you can use cloud-specific tools also. You can use cross-platform cloud tools also like Terraform. So it is all up to you. You just need to include the right commands into your YAML file. So that section which takes care of your servers, your environments, is something which falls in the category of infrastructure as a code. Is that clear?
Yes.
So
Yes.
if I talk about the best practices for designing and implementing CI/CD pipeline, can we quickly summarize that? Pipeline also should be very simple and straightforward to start with. Iterate the pipeline with modifications as you progress with your application. Whatever demands coming in, whatever the request changes are there or change requests are there, accordingly you modify your YAML file also to set up your environment. Make sense? So it is a iterative development in an agile way, which makes it adaptive also, right? Like in our case itself, we just displayed deploying to production. But if my requirement says no, apart from displaying this, actually get it deployed to Azure Web App Service, I can actually put the command for that under run after echo, right?
Yes.
Okay, so start simple and iterate. This is the first step. Then use version control system to track and manage your source code at all times, so that you can ensure all the code changes are committed and being pushed to the repository. And you can roll back to any version whenever required if you see something went wrong. Correct?
Yes.
Next, focus on automation. Whatever is possible to be automated, use automation up to the fullest extent. Right? Automate as many tasks as possible, including code compilation, testing, deployment, and as far as possible, avoid the manual interventions in the pipeline so that you can reduce the errors and save your time, right?
Yes.
Now, just like with the code, your script file, the YAML script file can also become very big and complex at times. So in such cases, the same coding standards can be applied over here where you can modularize your YAML scripts. Break your pipeline into modular components or stages, which can be reused at different times for different projects, which will promote the consistency and reduce the redundancy or duplication of efforts. Yes.
Yes.
Next is fail fast, fail early. So implement the checks like code compilation, testing at various levels like unit testing, integration testing, integrate the code analysis also, static code analysis also, right? So that you can actually catch the issues as soon as possible in the pipeline to reduce the overall debugging time. And configure your pipeline in a way that if there is some error, there is some issue, the steps in the pipeline further should be automatically discarded. Your pipeline should declare itself failed the moment it encounters an issue or error, right?
Right.
So that you need not wait for the completion of the pipeline just to fix the error. Fail where the error is. Quit there itself and quickly focus on fixing the error and then redo the execution of the pipeline, right? Manual pipelines or manual executions of the pipeline should also be avoided as far as possible, because manual executions might depend on many things being committed first and then executing the pipeline, which will be time consuming, right? So that will not be resulting in continuous integration and continuous deployment. That will be planned integration and planned deployment. Correct?
Yes.
And wherever possible, parallelize your builds and tests. If there are 2 or 3 class library projects into your application, try to run the build command parallelly and try to run the test cases parallelly on all those components so that you can save your time. Got it?
Yes.
Build artifacts, whichever are created, like the DLL, exe files, Docker images, containers, etc. Store all of them into some artifact repository, which is also versioned. Understood?
Yes.
Then we spoke about infrastructure as code. So wherever possible, in fact, try to accommodate infrastructure as code wherever you have a dependency on the infrastructure. This will create the same environment every time for your application whenever the deployment happens. And this can also be versioned, right?
Right.
Then for each deployment, new deployment, make it immutable. So each version has a separate, fresh, I would say disposable deployment or instance. So each deployment package will have its own specific configuration, which will automatically reduce the configuration drifts and simplifies the rollback. This version doesn't suit my need, so I want to go back to the previous version. I just roll back, means uninstall the current version. So each version deployment should be a separate deployment, fresh deployment. Understood?
Yes.
Always configure the continuous monitoring. If you don't do that, then the issues will not be possible to be detected early. These issues could be related to any logical errors being surfaced, any performance bottlenecks being surfaced. So if you have continuous monitoring going on, you can actually set up the alerting system also. And before the end user raises the ticket for the issue, you actually get alerted and you already work on the solution. Probably by the time user decides to raise a ticket, he gets the solution already. So the feedback about your application will be always positive in that case, right? Okay. So that is it for the day. And that is it for the Git and GitHub also. Tomorrow, 9:30, we will meet and we'll be starting with Node.js. Okay. Is it fine, guys?
Yes.
Yeah.
Okay. So see you tomorrow at 9:30 and just do some pre-study on Node.js. Maybe you can go through some basic tutorials so that we can make the session more and more interactive. Okay.
Oh, Saket, Node.js means we are working on React.
Practically, it will be Node.js first, the server side JavaScript development.
Okay.
And then once we are done with that, we will be starting with React. Okay.
Very good.
So bye-bye, everyone. See you tomorrow at 9:30.
Yeah, thanks, man.
Thank you very much, Jamborwa.
Thank you.